6.2, the natural base e. E is a number that's just like pi. It doesn't repeat, it doesn't terminate. It's called a transcendental number. And there are ways of getting e. The one who discovered it is Euler. His name isn't spelled O-I-L, like oil, but it's Euler, and it's E-U-L instead. So that's why it's letter E. Now, one way to get this, there are several ways, but one way is to see that 1 plus 1 over x to the power of x approaches e as x goes to infinity. So that's like a limit as x goes to infinity of this. It approaches that. For example, if you were to put in 1 plus 1 over 10,000 all to the power of 10,000, you would see that that number is going to be fairly close to this. Of course, it'd be closer if it were 1 billion on the bottom and as an exponent. Now, you can treat e as a variable when you simplify expressions. For example, this is just e to the 7 plus 4, or 11. 8 goes into 24 3 times, e to the 8 minus 5, or 3. Keep the larger one, subtract off the smaller one. And in this case, it's going to be 10 to the third e to the negative 9x. I'm writing this out 3 times, which means there are 3 of these and 3 of these. At this point, you can see that that's going to be 1,000 e to the positive 9x. In this part, it's talking about the growth and decay. Notice that the growth is e to the x. Remember, e is actually a point that is a number that's around 2.718. Now, when you have e to the negative x, what that really means is y equals 1 over e to the x. And this number, y 1 over e to the power of x, that number is between 0 and 1. So that means that's why it's going to be a decay. So there are a couple problems with that. And the question is, say if it's a growth or decay and then graph, this is going to be a decay because it's e to the negative 1, and this is going to be a growth. So how do you graph this? A decay looks like this, and a growth looks like this, just like we had before. So we want to label some points. These points, let's see, if I put 0 for x, this becomes 1. 1 times 4 is 4. If I did the same thing here, e to the 0 is 1 times 2 is 2. And you want to label a couple other points. So if I were to put down, for example, a 1 for my x, that means, let's see, y equals 4e to the negative 1, which is y equals 4 over e. That means that this right here is going to be 4 over e. Now, you can keep the e right in there. You don't have to approximate. That makes it a lot easier to graph. Similarly, on this one, if you put in a 1, you would get 2e squared. So that means if you had 1, you can put in 2e squared. Again, showing points in your graph makes it so I understand that you know how to graph those exponential growth decay with ease. With ease and with ease.